All right, good morning, guys. Happy Friday. Can I get a thumbs up that you guys hear me and see the presentation okay? Okay, so we are going to start section 5.6 today. I know it feels like we're kind of really moving, but all these log properties kind of like intertwine, and then these properties are going to help us in section 5.6 when we go to solve a more complicated log equation. So we're going to start in section 5.6. These are the actual notes from your book. I didn't type up my own if they look a little bit different than usual, but this is section 5.6 on logarithmic and exponential equations. We're only going to get to the log equations today. We'll save the exponential equations for Monday. All right. So what they did is they've listed in kind of like one safe place for you all of these log properties. You know, how you can break a log apart, how you can put a log back together, what it's okay to do with logarithms. So all of your properties are listed right here for you. I'm not going to read them, but there they are. All right. So when we start solving log equations, they've given you a list of steps as to what you can do to solve log equations and certain strategies that you can use. I just want you to realize that today there's going to be two types of log equations when we go to solve them. There's going to be one where it's going to be you want one log equal to a number. That's one type of log equation we're going to get into solving today. Or you may get into an equation where it's a log equals a log. Okay, so just in general, those are the two types of equations we're going to see, and depending on which one it is, we may use a different solving strategy, okay? But just remember, at the end of the day, a log, I missed a chat, I think. A log, go ahead, Michael.
I think you wrote one log twice because you were saying a y. One log is a y.
If I said that I did not mean it, I apologize. Your two types of equations are going to be when one log equals a number or when one log equals one log. I apologize. If I said y, I did not mean to.
Okay. I was like,
Okay.
I thought that was an error in the writing.
Trust me, listen, I make enough mistakes, so it very well could be. So I definitely apologize if I said the wrong thing. But this is what I wrote is what I meant. You want one log to equal one logarithm. Okay. All right. So let's look at them on the back. And then again, depending on which one it is, we'll kind of depict the strategy that we use. And I just want you guys to remember that at the end of the day, a log and an exponential are inverses. They will undo each other. So if we need to get rid of a log, we can use an exponential. If we need to get rid of an exponential, we can use a logarithm. Okay. All right. Here we go. And guys, normally these go pretty darn good. I don't find these to be overly complicated. So I know coming off of some of the properties, students are kind of like, oh, I don't know how I feel about these logs. But the equations, they're not that bad. All right, here we go. So look at example 1. Solve logarithmic equations. So solve the following equations. Now, guys, also remember that you're going to want to check your answers for extraneous solutions. You do not want to get an answer to an equation that then would mean that you would be taking the log of a negative number or 0. Because remember, the domain of a log is that you have to take the log of something that is greater than 0, because only numbers greater than 0 come out of an exponential. So those are the only kinds of numbers that could then go into a logarithm. So you want to make sure that whatever answers you get do not result in you taking the log of a negative number or the log of 0, because they would be then extraneous solutions and you are going to disclude them from your answers. All right, here we go. So the first one, it says log base 3 of 4 equals 2 times log base 3 of x. Well, right now I can kind of see that this is leaning towards 1 logarithm, base 3, equals 1 logarithm, base 3. I just want to get this log kind of more isolated. So let's throw this factor of 2 back up as an exponent. And then it'll say log base 3 of 4 equals log base 3 of x squared. So now it definitely says 1 log base 3 equals 1 log base 3. So think about common sense why. If log base 3 of this is equal to log base 3 of that, The only way these two logs could actually equal one another is if what you were taking the log of was equivalent. So in a situation like this, you really can just drop the logs and just take whatever it is taking the log of and say, well, then they must be equal to one another. If log base 3 of this equals log base 3 of that, then this and that must be equal. Now, guys, at the end of the day, you could also think of it as, well, what would undo a base 3 log? I could exponentiate both sides to a base of 3, and now a 3 and a log base 3 cancel, and a 3 and a log base 3 cancel, and again, you're left with 4 equaling x squared. So when it's a log equals a log, drop the logs and just set what you're taking the log of equal to one another. And now we have a very simple equation to solve. I'll square root both sides, and I'll get x equals the square root of this, creates plus or minus of that, positive or negative 2. So right now, the two answers to this equation are positive or negative 2. But hold the phone. If x is positive 2, that means I'd be taking log base 3 of 2. Perfectly fine. But if x was negative 2, then I'd be taking log base 3 of negative 2. And I'm not allowed to do that. Ooh, my camera just went. Guys, am I okay? Did I go out on you guys? Am I all right? Thumbs up? Good. Okay. All right, perfect. So in this case, you would not be allowed to include the negative 2. Only the positive 2 stays as a solution, because when you plug it into the original equation, you'd be taking log base 3 of negative 2, and that is not allowed. Okay, so we just keep the positive 2. Negative 2 is extraneous. So again, pretty simple, right? If a log equals a log, drop the logs and set what you're taking the log of equal to one another. All right, let's go over to this one. So in part B, it looks like I have a log base 2 of x plus 2 plus log base 2 of 1 minus x equals 1. So it's kind of leaning towards a logarithm equaling a number. However, I want one log to be involved in this equation. I don't want multiple logs. So since these are both base 2 logs separated by addition, I can use my property that says I can put these 2 logs back together using multiplication, and I'll have one log. So I'll have log base 2 of x plus 2 times 1 minus x equals 1. So now I have one logarithm equaling a number. So when one log equals a number, this is where you're going to want to remove the log. And how do we remove a log? We exponentiate. I can base both sides to a base of 2. So I can put this to a base of 2 because I know a base 2 exponential and a log base 2 will cancel, but then I'll have to base the other side. Again, this is kind of something that you've probably never been asked to do before, but you're just basing or exponentiating both sides to a base of 2. So now the 2 and the log base 2 cancel. I'm left with x plus 2 times 1 minus x equals 2 to the first, because this is a base of 2, to a power of 1. Now that equals 2. So the logarithm has gone. Now you're just solving what looks like it's going to become a quadratic equation once I FOIL this out. All right. Now, again, your book will say 2 different things. You could either exponentiate both sides, or they'll just tell you to rewrite this logarithmic statement in exponential form. And that's basically use your log loop. And your log loop would say 2 to the first power equals that answer. And you end up with the exact same statement. I like you guys to get used to basing both sides. Get used to that technique, okay? All right, here we go. Let's FOIL this out so we can solve it. I'm going to get x minus x squared plus 2 minus 2x equals 2. All right, that's going to get me a negative x squared. I'm going to get a negative x plus 2 equals 2. Well, guys, let's move everything to one side so we can solve this quadratic equation. I'm going to move everything to the right because my quadratic leads with a negative. So I'm going to add that way. So I'm going to go x squared plus x equals, when I minus the 2, though, I get 0. And then I'm just going to pull out a GCF. And then when I set each factor equal to 0, I'll get x equals 0 and x equals negative 1. And now just check that neither one of those are extraneous. Is any of those answers going to result in you taking the log of a negative number or 0? So if x is 0, I'd be, go back to the original, I'd be taking log base 2 of 0 plus 2 is 2. Perfectly fine. Log base 2 of 1 minus 0 would be 1. Perfectly fine. 0 is a keeper. Negative 1. Log base 2 of negative 1 plus 2 would be positive 1. It's okay. 1 subtract negative 1 would be 2. So both of these are perfectly acceptable answers. And you end up with 2 solutions to this logarithmic equation. All right, can I get a thumbs up if that seems pretty easy enough? Yes? No? Okay, like I said, normally once you get that log removed, the equation itself is a quadratic or a linear equation. Go ahead, someone was going to say something?
Yeah, I have a question.
Go ahead, Jay.
Where did you get the 2 on the...
This 2?
Right.
Because
right.
when I got rid of my log, in order to get rid of a base 2 log, I used an exponential of base 2. So basically, you're basing both sides to a base of 2. So a base 2 exponential raised to a log base 2, they cancel. And now this is a base of 2, and now this becomes a power of 1. So 2 to the first power is 2.
Okay.
Is that okay?
Yeah.
Perfect. All right, let's continue on. Look at, let's go to the next ones. Again, it's just solving logarithmic equations again. So look at this one. So now I have 2 logs on this side equal to 1 log on this side. Let's gear this towards getting 1 logarithm on the left because I can put these 2 logs back together using multiplication since they're separated by addition, and then it will equal 1 log on the right. So let's put these 2 back together. So this becomes the natural log of x minus 1 times x, which I'm going to throw that in front just to make it look a little bit more normal. All right, I'm putting this x and the x minus 1 back together equals the natural log of x plus 2. Okay, so now you have 1 natural log equals 1 natural log. So 2 ways to think about this. If the natural log of that equals the natural log of this, well, then they have to be equal in order for those logs to be equal to one another. Or you could think of it as I could base both sides and undo both of these natural logs right now. If this is a base e logarithm, then I could base both sides to a base of e, and now a base e exponential and a log base e cancel. I'm left with x times x minus 1 equals a base e exponential raised to a log base e cancel, and I'm left with x plus 2. So however you want to think about this one, whether you want to base both sides or whether you want to think about if this log equals that log, then what you are taking the log of must be equivalent. All right, and now let's solve. Looks like it's going to be another quadratic. So why don't everybody on your own multiply that out, get everything on one side. Let's get this ready for either factoring or the quadratic formula. All right, get everything on one side set equal to 0. Guys, you could try to factor this now, but I'm telling you right now, you are not going to find numbers that multiply to -2 and then add up to -2. So it looks like this is, unfortunately, a quadratic formula problem. So I'm going to plug my A's, B's, and C's into the quadratic formula to start getting the solutions to this equation. Now, I'm assuming your homework is either going to ask you for the exact answer, which you would leave in simplified form, or they may ask you to take a decimal and round it. We'll have to see. I'm going to have to convert to a decimal in the end either way, just to check for extraneous solutions. All right, so x will equal the opposite of b plus or minus b squared minus 4 times a times c, all divided by 2 times 1, 2 times a. Let's clean that up. Looks like it'll be 12. I think that's going to be the square root of 12, which is then going to be 2 root 3 when you simplify it. All over 2. So you get x equals 2 plus or minus 2 root 3 over 2. Well, guys, everything on top divides by 2, so that's going to simplify to x equals 1 plus or minus root 3. So those are your exact solutions, 1 plus or minus root 3. I'm going to get the decimal versions now just so I can check for extraneous solutions. So if x was 1 plus root 3, or if x was 1 minus root 3. I believe this is going to be about 2.7-ish, and this will be about negative 0.7-ish if you just get an estimate to check for extraneous solutions. So if x is about 2.7, I'll go back to the original. 2.7 minus 1 is going to be a positive number and not 0. 2.7 plus 2 is going to be a positive number and not 0. So he's a keeper. This is a keeper. And again, whether or not they ask for the decimal or the exact answer, just pay attention on your homework. And then 1 minus root 3 is negative 0.7. Negative 0.7 minus 1 is a negative number. So right then and there, he's out. This is an extraneous solution. The only answer you can keep is 1 plus root 3, or about 2.7. Thumbs up. Everybody still good? Yes? Okay. I'm going to ask you guys to try part B. How would you tackle part B? It looks like you have 2 logarithms equal to a number. So I would try to get this down to 1 log equals a number. So how can you get these back to being 1 base 4 logarithm? I'm going to give you guys a head start on that one. Looks like I'm missing Aiden and Javier. Please correct me if I have missed you. Right, you can put these 2 logs back together using division since they are both base 4 logs separated by subtraction. And now I would say get rid of the log by basing both sides. You could just rewrite it in its exponential form as per the book. I want you guys to get used to basing both sides. So if this is a base 4 log, I'll base or exponentiate both sides to a base of 4. They cancel. H plus 3 over 2 minus h equals 4 to the first is 4. I'll throw it over 1. And then, guys, it's a linear equation. Cross multiply. It's a proportion. And solve. You should get h is 1. And as long as 1 is safe, and we will not be taking the log of a negative number or 0, we keep it. And 1 plus 3 is fine. 2 minus 1 is fine. We are good. Can I get a thumbs up if anybody got a 1? Everybody good? Again, it's very hard to tell. Good? Okay. All right. Look at the one down here. So they kind of throw you for a little bit of loop in part C. Part C is you have 1 log on the left. It equals a number plus a log. That number is going to screw you up in the sense that we don't have a log equaling a log, and I don't have 1 log equaling a number. You could do a little bit what we were doing yesterday and think of a way to rewrite the 1 and why you would have had a 1 there in the first place inside of a base 10 log. I suggest this. In a case like this where you have a number involved that you're not going to be able to kind of condense back with a logarithm, move all your logs to one side. Move your logs to one side, keep the number on the other, and then you'll be able to put the logs back together using a property, and it'll just be equal to 1 number. So I'm going to minus this log to that side to leave the number by itself on the right and get all my logs on one side. So that would leave me with the log of 1 minus c. And then I'm going to minus the log of 1 plus c over, and then it will just equal 1. Okay? So now you can put these 2 logs back together using division since they are separated by subtraction. So let's put them back together as 1 log, and then we'll have 1 log equals a number. So then I'll have the log of 1 minus c over 1 plus c, and it equals 1 now. So now think about how you could solve this equation, right? Now I have 1 log equals a number. Let's get rid of the log. This is a base 10 log. So you can base both sides to a base of 10 or use your log loop to rewrite this in exponential form. So a base 10 So now a log base 10 and a base 10 exponential will cancel. I'll be left with 1 minus c over 1 plus c equals 10 to the first is 10. Throw it over 1 and we'll do the exact same thing again, and let's cross multiply and solve. So I'll meet you guys at the end. Everybody solve this for c. Give you just a smidge start.
After we're done with this problem, can I see B again?
Yeah, absolutely, Michael.
Thank you, by the way, I'm sorry.
Oh, don't ever apologize, Michael. You're fine. Trying to keep that on screen, maybe get you a little more vision of B. And then check your answer with mine. Negative 9/11, guys, it's a number that's kind of close to -1, but not yet. 1 minus negative number will be positive, and 1 plus negative point something is still going to stay positive and not 0, so it's definitely not extraneous, and we can keep it. Okay. Can I get a thumbs up if everybody's okay? One more to go. Everybody good? All right. I'm going to let you guys start part D. Think about how you want to approach that. Again, that 2 by itself kind of limits what you can do to that right side. So I think you should do what we did in part C and try to get your logs on one side equal to a number. This one's going to be a little bit weird, guys, because the answer is going to have E in it. It's not going to be a pretty answer, but we want exact, so we have to leave E in it.
And then I guess while they're starting that, can I see B? Thank you.
Mm-hmm. And now here's where this problem starts to take a turn, where E should show his face. Either way you want to think about this. To get rid of a natural log, a base E, you'll need a base E exponential. So you can base both sides to a base of E, which is a number that is the limit of 1 plus 1 over n to the power of n, which is approximately 2.718. All right. Or you could just rewrite this in exponential form using your log loop. I'm going to base both sides. All right, so you're left with this. Now your job, remember, your job is to solve for m. M is the only variable in this problem. So since we have multiple m's, our job is going to be to get all m's on one side and then everything else on the other side so we can isolate m to solve for him. So let's cross multiply to get rid of these fractions. We're going to get e squared times m minus 3e squared equals 3m plus 1. All right, I'm going to minus my 3m here, and I'm going to add my 3e squareds that way, because 3e squareds, guys, that's a number. It's an ugly number. It's an irrational number, but it's a number. All right, by doing this, by putting all of your m's on one side, they now have a common factor of m that you can factor out. So factor out an m. And then just divide both sides by e squared minus 3. And your exact answer is 3e squared plus 1 divided by e squared minus 3. And we would never cancel our e squares over all of this addition and subtraction. So that is your simplified final answer. And if you plug it into your calculator, guys, I don't know if I can show this. I don't have my graphing calculator. But what did I say? It's 3. It's not on. 3. I'll put in parentheses. 3 e squared plus 1 divided by e squared minus 3. All right, so I have 3e squared plus 1 divided by e squared minus 3. Hit enter. It's about 5.3. So as long as that's not going to cause an extraneous solution, we're going to keep that. 5.3. 3 times 5.3 plus 1 is not negative, and it's not a 0. 5.3 minus 3 is not negative, and it's not 0. So it's a perfectly acceptable answer. And there you have it. So if it's a natural log, it's going to take e as part of your answer. So your answers are probably going to look funny when you're solving a natural log because you're going to have e as part of that answer. All right, can I get a thumbs up if you guys are okay? Okay. All right, so guys, that's log equations. The last page of your notes starts the exponential equations, which will take logs to solve. So I'm going to stop there. We can start those ones on Monday. So I did create a homework for these equations, guys, but I didn't make it due till Monday night. In case any of you have a crazy weekend, it kind of gives you the weekend plus Monday after school to kind of tackle it. It's pretty quick. The equations, like I said, they become fairly basic, like linears or quadratics, once you remove the logs from the actual equation, okay? So you do have last night's problems, though, on just those simplifying and using those properties. That's due tonight. And if anybody has an issue with that, just let me know, and I could obviously give you an extension. It doesn't matter to me. I just don't want you guys to be overwhelmed, okay? All right, so I'm going to double check the attendance, but otherwise you guys are going to be good to go if you don't have any questions, and just make sure that you can try to get some of this homework done. All right.